Alright, so here is part 2 of our assignment. Again, I can only make 30-minute videos, so I kind of have to put this in. Alright, to 2 different videos. So, first thing we're going to do here is analyze, and so you'll notice that we end up having all of these pieces here. They also want the X-Intercepts and the Y-Intercepts, so we will want to note those as well. So taking a look at our first piece here, if you can factor, that's the best option, but it turns out that neither of these is very factorable, and so instead we could get the imaginary solutions, but again, those aren't going to be an intercept of any sort. So probably best if we look at an image of this graph. And so we end up with an image that kind of comes in from the left here, goes up, and then it goes back down. So it turns out, as I was kind of mentioning earlier, the domain is all real numbers because there's nothing that kind of chops it up with a asymptote, because no denominator here can be 0. There are also actually no x-intercepts because again it's not intersecting that x-axis. There is a y-intercept, and so as you graph you can press trace and then enter in the value of x of 0, and in that case you'll get 0.8. And so then our range, as we look at what's an option in this image, from we have to kind of cap it at this maximum and then also at this minimum. And so as we look at that, that actually means that it's bounded. All right, because we have these two horizontal lines that restrict the vertical motion to the top and the bottom. So in that case, for our range, we're going to need to get the values of those maximum and minimum. And then we can write them here in extrema. So let's see. Second, calculate a maximum value. It looks like it goes from anywhere between 0 and 10. And our maximum is going to be 2.45 and then 14.23. And then the minimum value, again going to second trace, which is up to calculate. We can calculate our minimum value, and it looks like it's anywhere between 0 and 2. And it's going to be a minimum at, that is a weird number because it's giving me that scientific notation again. And that's because I was limiting it to 0, but the minimum is actually at negative 0.24, oops, rounding to 5, and then 0.77. All right. So that means that as we're looking at the range is between the y values of both of these, so that's its maximum and that's its minimum. So 0.77 is where our y's are sandwiched between. It is continuous because again there's no vertical asymptotes that make you jump and then continue your drawing. It is decreasing from negative infinity to this first minimum point, and so that's going to be at negative 0.025. Negative 0.25. And it's also going to decrease from that maximum point of 2.45 to infinity. Just kind of squeeze that in there. Okay. It's increasing between the minimum and the maximum, so it's going to be increasing between negative 0.25 and 2.45. Because of course that's the only part in the decreasing that was missed, so it must be increasing. And then there is no constant, so there's no like horizontal moment as you're going across here. Alright, so then we look for symmetry, and there's definitely no symmetry. Potentially you might think it could spin around, but those are not equal heights of things. Horizontal asymptotes, there are none. There's just a minimum and a maximum. Although it does kind of look like it might have a y equals, oh it is. The horizontal asymptote, because they are the same power here is going to be y equals the leading coefficient, which is 3, and then 1. And so our horizontal asymptote is actually at 3. So these two graphs kind of approach this value here of y equals 3. And so because of that, our end behavior is going to say the limit as x goes to negative infinity is actually the same as the limit of the function as x goes to positive infinity, because they're both going to be at that 3 from the horizontal asymptote. And then, we don't have any vertical asymptotes, so we won't do those as the approaching. All right. So then our next problem, again, the best way to kind of get your head wrapped around what's happening is to kind of first see an image. So if we go through and graph our x cubed minus 2 and x plus 2. So graphing that on a standard window, you kind of get a weird looking thing, but it does have a vertical asymptote here. It looks like it's at -2, but we'll just double check. And then the image itself kind of comes up like that. Alright, and so remember we're doing our x-intercepts and our y-intercepts as well. And so before we go on, I may as well do those right now. So my y-intercept, again, is going to be at an x of 0. So trace implant a 0, and we get 0, -1. And then the numerator equal to 0 would be your x-intercept. So if we add a 2 to both sides, we're asking what is the cube root of 2, because that's going to be our x value. So cube root is in your math menu, and type in a 2 and we get a super decimal, unless you randomly have a 0 out front. Okay, so 1.26 is going to be our x-intercept. So 1.26 and then a 0. Alright, taking a look at our image, our x's are stopping, right, from positive infinity, but then stops at -2. And so we're going to put that into our domain, meaning -2 is the stopping point, infinity is the other stopping point, and the x's are all between those. The range does go all the way down and all the way up, so our range is all real numbers. Our continuity is, yes, it's continuous. It's increasing always. So anytime that you're on the equation, it's increasing. Then we have symmetry, which is none. It's definitely not bounded because the range is all real numbers. There are no extremas, so no minimums and maximums kind of hiding in there. No horizontal asymptotes, because as you see the equation itself, there is a larger numerator power than the denominator, and so then you have no rational roots, no asymptotes, horizontal asymptotes. Our vertical asymptote, as we said already, is at x of -2, and that's because the denominator has a +2, and so what makes it a 0 would be a -2. And so our end behavior ends up being kind of interesting. The limit as x goes to infinity is not so bad. So as it's going to the right, it's going to infinity. But then we have to do the limit as x goes to -2 from the right. So we have to kind of put pieces together because we can't actually come in from the left because there's no equation over here. We have to come in from the right, and then we also have to stop at -2. So that's kind of where this is coming in. And then we'll say that it would go to negative infinity because it's going down. So that's just the mathematical way of saying the equation goes to -2 and then goes down because it's a vertical asymptote. All right. Then our next piece here wants you to find the x-intercepts, the intercepts, asymptotes, end behavior asymptotes and graphing. So we've got our don't know what I'm writing there. Our X-intercepts, and we want our Y-intercepts if we have those. And then end behavior. And then we also want a graph. So let's go ahead and start with our graph, because again it's a little easier to figure out what's happening if you have that graph to look at. So x to the fourth plus 1 over x plus 1. Oopsie. Well, that's an annoying way of getting back there. Okay. So on a -10 to 10 grid, it looks like there's a vertical asymptote at -1, and you can confirm here. So x of -1 is your asymptote, and then the equation itself kind of has this like asymptote parabola shape. So turns out there are no x-intercepts. It's not intercepting that axis there. There is a y-intercept, so we go to trace, type in a 0, and we get 1. And then the end behavior is the fact that the limit as x approaches -1 from the right is infinity. But then the limit as x approaches infinity, positive infinity, so to the right, is infinity as well. So they both go up, but again, referencing that -1 from the right is where it stops. It does say graph the function together with its end behavior asymptote, and I'm assuming they mean kind of the path of this end point here, but we do not have that because we're not doing diagonal asymptotes, so we skip that part. Okay. So find the intercepts and asymptotes of the next piece. So again, we want the x-intercepts, the y-intercepts, and the end behavior. Wow, doing real well with writing today. Alright, so as we check out a graph of this, we've got x to the 5th, which we will add a 1 to and subtract 1. And we have another asymptote, and you can see it in the denominator again, because 1 would be where the denominator makes 0. And then the equation kind of comes in like that. And so we do have, if we trace, a y-intercept of 0, -1. And then it kind of looks like this is at -1, 0. And so if we just check by typing in -1, pressing enter as we're tracing, that is 0. So you can, of course, set the numerator equal to 0 as well, but sometimes it's easiest if you just look at the image. So again, you could have done this and subtracted and done the 5th root, which would have gotten you -1. So either way, algebra or your graph itself. Then we need our end behavior, and just like we had before, there's going to be 2 different end behaviors. So for instance, the limit as x goes to -infinity, meaning to the left. And then we're also going to have the limit as x goes to the number 1 from the left, because we're approaching from that left side. And the first one, the limit as we go to the left is going to be infinity. And then the next one, as we go to the right, it's going to be -infinity. Alright, and then we have our last example. So we want our x-intercepts, our y-intercepts, and our end behavior. So looking at an image of this very large equation. Alright, because it's got so much going on in here, we at least have, the graph itself looks ridiculous if you actually just take it for what it is on the calculator here. But it is a asymptote at x equals 1. Anytime you kind of see that like heartbeat piece, that's usually where the asymptote is. And so that right there is, again, too little pixels to be able to show this. So zooming in a little bit does help. So I'm going to go ahead and change my window to -5 to 5 just to kind of zoom in on those pieces. And so if you zoom in a little bit, you can definitely tell that it has this little like check mark thing, and then it goes up, and then it's actually going down here. So we've got going down to -infinity. And then you've got this piece that goes from the top kind of out there. All right. So we need our X-Intercepts, and so our X-Intercept kind of looks like it's at -1, but you just want to double check by actually typing in that number. And now that I'm looking at it, it looks more like -2. So if you press trace and type in -2 and it's not 0, or maybe 1.5, if none of these nice whole numbers actually gives you 0, then you can actually take the numerator and set it equal to 0. Or factor. And of course, if factoring doesn't work, then you can actually use the quadratic formula. However, I'm just going to cheat a little and go ahead and actually just use the calculating feature on the calculator. So it says if you press second and then trace, you can go to 0. And of course, as anything else, you're going to go left of where that 0 is and right of where that 0 is. And then you're going to get that number. And it's very close to -1.5, but its X-intercept is -1.49 and 0.03. And so again, you would have got that by using the quadratic formula, or you could have, and then plug that answer in, or again, you can just do it via the calculator here. Then your Y-intercept is a lot easier. You just need to type in 0. Oh wow, I didn't actually even press enter the last time. It's -1. That's why this isn't 0. That's so weird. Okay. -1.48 is our number there. Sorry. Alright. It's very close though. Alright, and then the Y-intercept plugging in as 0 makes -2. And so then we get to do our asymptotes. And it looks like 2 is a number that doesn't quite work here as it's approaching. So I'm just going to graph y equals 2 just to kind of see if that's where it is that it's aligning. And it is. So we are going to say that the end behavior, the limit as x goes to -infinity, and the limit as x goes to +infinity of the function is 2. So there's our horizontal asymptote, more of an end behavior asymptote there. Alright. It does also say in this one that we would want to graph the end behavior asymptote, so I guess that is this one right here. So, yay, there it is. Alright, so that was the end of the assignment. Perfect.